Okay, so now let's go to multi-year returns. And so instead of talking about within 1 year, let's talk about something that happens n years in the future. So for example, what if I go from $100 to $125? Well, if this happens in a year, that's 25%. But what if it happens over a 3-year period? How do I communicate how much I earned going from $100 to $125 over 3 years? And just a notation, we're going to look at the price at time 0 and the price at time n years in the future. Just to be a little confusing, sometimes the textbook and people use n, sometimes they use t. So it's at time 3 or in n years, and the percent change is the ratio minus 1. And so I can see that the amount that I earned over a 3-year period, the holding period return, the aggregate return, is this 25%. But it's very common to actually communicate not the aggregate over the 3 years, but how much I earned in any year. And so what I'm going to do is I'm going to distinguish between the holding period return, the HPR, and the annualized holding period return. And this is going to equal, well, Pn divided by n, but now I'm going to take this to the 1/3 power before I subtract my 1. And so here I can see that it's going to be 12.25 to the 1/3 less 1, and I get 7.72%. And so the common way to communicate going from $100 to $125 over 3 years is to say that we earned 7.72% per year. And so this is the annualized holding period return. In other contexts, we would call this the compound annual growth rate, generally not in finance, but in operations or in some other sales growth or something like that. This is also the geometric mean return or the geometric average return, and we'll revisit that as well. And so let's go to a spreadsheet and look at some other calculations. Okay, and we're at a spreadsheet, and I've got some numbers I made up. And what I'm looking at is the price on the very last day of the year, December 31st, or whatever the last trading day is, 2014, 15, 16, 17, 18, and 19. So notice I have 6 different prices. This is going to give me 5 years worth of returns. I'm always going to go close to close. I'm going to go year close to year close. And so the return was this 122 divided by 100 minus 1, and I can see, okay, that's 22%. And I'll copy, and I'll do Control-Alt-V for paste special, and I'll paste the formulas, F, and this is going to give me the returns. And I can see that I earned 22%, I earned 23.77, 34.1, which is going from 93 to 125, and so on. And what I can do now is I can compute the arithmetic average return, which is just going to be the average. And this tells me that I had an average of 11.4% return over this time period. But I also want to compute the geometric mean return. And the geometric mean return, it's not easily done in Excel without having to do a little bit of computation here. I'm also going to compute the standard deviation. And this is standard deviation. I get 27.61%. To do this, what I want to know is how much did I earn on an average year to bring me from 100 to 150 over this 5-year period. I starting with 100, I'm ending with 150. I can see I earned an average of 11.4% over this 5-year period, but I also want to compute the geometric mean. And to do this in Excel, I need to add 1 to each of the year's returns. And then I'm going to do Control-Alt-V and then formula so I don't lose my Control-C, Control-Alt-V formula so I don't lose my line there. Okay, and so now I have the return in each year. To get the geometric mean, what I'm going to do is I'm going to take the product of each of these values. I'm going to take the product of each of these, and I'm going to take it to the 1/5 power, subtract 1, and I get 8.45%. And so this is an important number. So again, here's the holding period return. The holding period return is just the 150 divided by the 100 minus 1, I earn 50%. That's pretty obvious. But the annualized holding period return is 8.45%. Now we'll talk about the difference between this arithmetic mean, 11.4, and this geometric mean, this 8.45, but let's look at it here, and this is what this table is. This table says, well, what if instead of earning 22 and then losing 23 and then plus 34 and minus 12 and then 36, what if there was a single return value that I could place in this table such that I earned the same amount in every year but still went from 100 to 150. What return is that? And that is that 8.45. So if I go from 100 to 108.45 to 117.61, here I didn't do as well, here I did much better, here I'm a little ahead, here I am a lot ahead of sort of the more volatile, and here I end up at 150. And so the geometric average, which is also known as the annual holding period return, is the one number I can earn instead of all of these values, which brings me to the same place. And here is the same example with the numbers all computed. And here I have actual S&P 500 data. And what I did was I went to Yahoo Finance and just pulled the December 31st, or the last trading day of the year close for the S&P 500, and I can see how we did. And here we lost 0.73% for 2015, 2016, 2017, 2018, and then 2019. And I can see the arithmetic average was 10%, but this is very important, the geometric mean is 9.43. And the way I interpret this 9.43 is that instead of realizing these 5 different returns, if instead it would have been 9.43, I would end up in the exact same spot. If I started with the 2058.90, I would end up with the 3230.78. And so this would lead me to the same path. Again, difference between the arithmetic mean and the geometric mean. And then again, this is the holding period return, which is 56%, but this is the annualized holding period return, which is the 9.43%. Let's just take a quick look at the formulas. Here is the equation for the geometric mean, which is also the annualized holding period return. It's the terminal price divided by the initial price to the 1 over n. Here it is with prices. Or I can do it with returns by computing each year's return, adding 1, taking the product, and then also taking that to the 1 over n. And those are both shown in the spreadsheet. The arithmetic mean return is just the average of the annual returns. Okay, let's talk about the difference between these. What does it mean? And we'll do another example. We'll talk about going from $100 at time 0 to $80 at time 1, and then back to $100 at time 2. And so that's the question. What happens if I go from $100 to $80 and then back to $100? And let's go back to the spreadsheet and see what this looks like. Okay, so let's enter our data. I have my different time periods. I have time 0, I have time 1, and I have time 2. We'll center that. And then I have my prices at the different times. And I have 3 prices. I start at $80. I go to 100, and then I go back to, I start at 100. I go to 80, and then I go back to 100. So those are my 3 different prices. And now I want to know my returns for each period. My return over the first period is 80 divided by the $100 minus 1. And so I lose 20%. But if I go from 80 back to 100, I gain 25%. And that's where this gets a little confusing or a little interesting. So now, instead of having, well, let's calculate the average return. If I calculate the average, and actually I'll just do it this way. I'll just take the minus 20 plus the 25, and I can see that's actually 5%. When I divide it by 2, I get an arithmetic average of 2.5%. And so the way to think about that is that I have some sort of process or company or return or stock or machine. And half the time this thing loses 20%, and half the time it makes 25%. And so the average, my expectation, is going to be a 2.5% average return. But let's look at the geometric average. And so remember, the way I do the geometric average is I'm actually going to first take 1 plus the return, 1 plus the return in each period. And to calculate that, I'm just going to go down and I'm going to equal 1 plus, equals 1 plus r, close parenthesis. And this isn't really a percentage, so I'm just going to leave it that way. And now I get 1.25. And remember, now I'm going to take the product of these. This is going to equal this times this. And let's see when I multiply those together. Oh, I get 1. Okay. And then I'm going to take this to the 1 over 2 power, which is still 1. And then I'm going to subtract 1, and I get 0. Okay. And so now I have an arithmetic mean of 2.5%, but I have a geometric mean of 0%. Let me think about this. So the geometric mean is also the compound annual growth rate. It's also, well, the holding period return. And I can see that if I start with 100 and end with 100, then my holding period return is really 0. And so this is an important distinction between the arithmetic average, which is just sum up the returns and divide by 2, versus the geometric mean. If I make 80, if I lose 20 and then make 25, if I go from 100 to 80 and then back to 100, I can see I net 0. And here I have the same calculations again, going from 100 to 80 back to 100. The average return, remember I have two averages. Over the first time period, I lost 20. Over the second time period, I made 25. And so the arithmetic average is that 2.5%, but the geometric average, or the holding period return, is going to be 0. Okay, so which better describes this relationship of going from 100 to 80 and back to 100? Is it the arithmetic mean or is it the geometric mean? Well, it depends. We have sort of two different questions. So the two questions are, what was the average return in any year? And we can see that the average of the returns was 2.5%. But what annualized average return did I earn over the period? Well, this is going to be that 0%. So back to our original spreadsheet, and we can look at the 100 to 150 over 5 years, and then the S&P 500 over the 5 years. And let's just look at this in the context of the geometric average and the arithmetic average. So this is the $100 to $150 over the 5-year period. I know that the cumulative total return was this 50%, but given these different returns, the 22, the 23, the 34, the 12, negative 12, and the 36, I know that my arithmetic average is 11.4, but my geometric average was the 8.45. And again, I can see that if I earned 8.45 in every year, that would bring me to the 100, from the 100 to the 150. And so my arithmetic mean is 11.4, but my geometric mean is the 8.45. And here are the two questions. The first question is, how much do I expect to earn in any year? And so given that I have this process, this investment, this company, this investment advisor, and sometimes they earn 22 and sometimes they lose 23 and then they make 34 and they lose 12 and they make 36, in any year, I would expect to earn 11.4%. But if I had held this investment over this period, I would have earned 8.45. And now just looking at some actual data, the S&P 500, I can see that over this year lost 0.73, the next year made 10, the next year made 20, the next year lost 6, the next year made 28.8. On average, in any year, I would have earned 10.17%, but 9.43% is the amount I would have had to have earned in every year to bring me from the 2058.90 to the 32.30 5 years later. And so again, the two questions, what return can I expect next year? That's the arithmetic mean. What return can I expect over some time period, or what would I have earned over that time period? That's the geometric mean. These are the two questions. Okay, next, there's a very important relationship, and that is that the geometric mean is approximately equal to the arithmetic mean minus half the variance of the returns, standard deviation squared. And so note that if this is not 0, if it's positive, then the geometric mean will be less than the arithmetic mean. And so we can approximate, given an arithmetic mean and given some variance or standard deviation, which gives us the variance, we can actually approximate the annualized holding period return given these two values. And I'll show you using some data.